Okay, the next thing we want to look at is gauge pressure. Your book discusses gauge pressure on page 3. A lot of people misunderstand what gauge pressure is, and this is a valuable and common tool that's used in natural gas processing, so it's important that you understand the meaning of gauge pressure. And once again, I think it's helpful to use our scuba tank example. You got a gauge on the scuba tank that tells you how much pressure you have in the scuba tank. And if you read in your book, you'll see that it says that gauge pressure is the difference between the pressure inside the container and the atmospheric pressure. This is on page 3. Gauge pressure is the difference between the pressure inside the container and the atmospheric pressure. Now, first of all, what is atmospheric pressure? It's just what it says it is. It's the pressure of the atmosphere. And it's usually represented with a P and then an ATM as a subscript. Now, atmospheric pressure varies depending on what your elevation is. If you're at sea level, it's one thing. If you go up in the mountains, it's less. But standard atmospheric pressure is at sea level, and it's 14.7 pounds per square inch. That's atmospheric pressure. You need to learn that number. Atmospheric pressure is equal to 14.7 psi. So what is gauge pressure? When your book says gauge pressure, that's P sub G is equal to the difference between the pressure in the container and atmospheric pressure. I think the easiest way to learn this is to consider a situation where you open the valve on your scuba tank and you let all the air in the scuba tank come out. So you have an opening between the inside and the outside. Air can go in and out. Now, if you open the valve and you say you let all the air out, you did not actually let all the air out. What you have is equal pressure, because air can move wherever it wants to. So if you have 14.7 psi, that's atmosphere, outside your scuba tank, what are you going to have on the inside? It's going to be equal, because it can go wherever it wants to, so it's going to equalize. So on the inside, you're going to have 14.7 psi, which is your container, inside your container. That's the pressure that's being exerted by the collisions of the air on the walls inside the tank. If your valve is open, you're going to have equal pressure. What does your gauge say if you've let all the air out? Well, you haven't let all the air out, but that's how we describe it. And what your gauge says is 0 psi. When your vessel or your tank is open to the atmosphere and allowed to come to equilibrium with the atmosphere, then you have 0 psi gauge pressure. And that works out according to this equation. Because what this means is the gauge pressure is equal to the pressure in the container, which is 14.7 psi, minus atmospheric pressure, which is 14.7 psi. So gauge pressure is 14.7 minus 14.7 is 0 psi. So when your gauge pressure is 0 psi, it means you got the same pressure inside your vessel as you have outside the vessel. So let's say your scuba tank is empty. You breathed all the air out. If you actually emptied all the air out, you'd have a vacuum. If you actually had an actual pressure in here of 0, you'd have to pull a vacuum on it. So 0 psi doesn't mean there's nothing in there. It means the pressure in there is equal to the pressure outside. So if you take it back to the dive shop and they put air back in there, say they pump it up to where the gauge says 100 psi is your gauge pressure, okay? What is your actual pressure inside if your gauge pressure is 100 psi? Well, you go back to this equation. Gauge pressure is 100 psi. That's equal to whatever's actually in the container minus 14.7, which is atmospheric. So your equation to solve is 100 psi equals whatever it is inside your container minus 14.7 psi. So how do you solve that? You're going to add 14.7 to both sides. So 114.7 psi is equal to the pressure inside the container. So a scuba tank that has a gauge pressure of 100 psi has an actual inside pressure of 114.7. Because the gauge pressure is telling you the difference, how much above atmospheric pressure is the actual pressure inside. Need to be sure you understand this concept. Now your book also talks about absolute pressure. Absolute pressure is actually the same as the pressure inside the container. They say absolute pressure is equal, this is also on page 3 of your book. Absolute pressure is equal to gauge pressure plus atmospheric pressure. Well, if you rearrange that to see what gauge pressure is equal to, gauge pressure is equal to absolute pressure minus atmospheric pressure. If you compare that to our equation over here, the absolute pressure is referring to the true pressure of what's inside your tank, whatever that is. So absolute, and that's written as PSIA, pressure absolute, represents absolute pressure. So that's the actual true pressure of the gas inside the tank. So be sure you understand when we're talking about gauge pressure, the difference between the gauge pressure and the true pressure or the pressure of the container. The gauge is showing you the difference between what's inside and what's atmospheric pressure. And what's inside is the gauge pressure plus atmospheric pressure.